section?
No, ma'am.
Any friends from B9 section?
I have a friend.
You have? Okay,
Yes.
actually, B9 student also needs to join the same lab.
Right now?
Yes. But none of them joined, actually created the list for both the sections. I think again they deleted that section from. Can
Do
you
you
send
want?
me? Do you have the link?
I have the link. Do you want me to share it to them?
Okay, yes, yes. You need to share.
Yes, ma'am.
Thank you. 82 participants right now. Hello, B9 students. B9. Anybody from B9?
Yes, ma'am.
Actually, this is a common session for both B9 and 11. Okay. Is it visible in your Moodle? This link?
Yeah, no, ma'am. There is another
Actually-
link for 10 a.m. to 11 a.m.
10 to 11?
Yes, ma'am. That is like inactive link or something.
Sorry, when today 10 to 11 or tomorrow?
Today, ma'am.
Today 10 to 11 for which lab?
SE, ma'am. Software engineering.
No, this is not software engineering. This is laboratory time. What is your laboratory time actually? SSC laboratory time. Actually, for the subject, you have both theory and laboratory. So SE lab time. Please check your timetable. Maybe in the timetable, they won't mention my name. It's a Fanikumar surname, HOD surname.
Yes, ma'am. There is
Yes.
no class for lab time. I mean, we don't have any link in Moodle for lab.
Actually, I requested Moodle people to join your list with my account. Then they already joined with my account, but I don't know why it's not visible in your Moodle. Actually, HOD sir is in charge for this lab. So maybe my name is not visible, but what is your lab time actually? Same timings only, right?
Yes, ma'am. We do have a lab period for this time.
Yeah, this is your lab time, right?
Yes, ma'am.
Okay, then anyway, I will take this lab. HODs are maybe HODs did not create the link. Maybe that's why it's not visible in your account. But every day you have to join. You have to join the same lab. Maybe if it's not visible in your Moodle, only one solution is I will share the link to one of your classmates or who is the CR, or I need one number, one WhatsApp number. I will share the link every week. If it's not visible, maybe I'm not the, as per the Moodle account, I'm not the in charge for the lab. Maybe that is the reason it's not visible to you. Okay. So someone please share your number, WhatsApp number. CS9. Okay, coming to CS11 students, not PIN number. I need your mobile number. And this is Chantana. Give me your mobile number. I will share that link to that word to that particular person, and he or she has to share in the group. Chantana. Okay. Chantana is the CR for the session. This section CR is Chantana, right?
Yes, nice.
Okay. Then I will send the link every week. She will share in the group. Maybe you have one class group, right?
Yes, ma'am, we do.
If it's a common group for everyone, means all the faculties group, means you can add me there, or else I will share the link to Chandana. Let me stop this. Okay. What about the subject? Is it started already? So started. Maybe you have an idea about the subject, right? Software engineering. Okay, for 11th section I started and I gave an introduction to the subject, and this laboratory is using in the design phase actually. For SC, what was SC? Anyone? What is software engineering? What do you mean by software engineering? Already I clearly mentioned the class, what it is, why we are learning software engineering. Anyone? So the lab is close to that theory. Anyone, please respond. Unmute and respond. Developing and maintaining of the software. In generally, we can call it as developing and maintaining of software. We are using some principles and technology, right? So using the principles and technology, how to develop a software. So what are the different development phases of software? What are the development? Okay, you said development. Then what are the different stages? Is it a single stage process? Is it a single stage methodology actually? What are the different steps or the stages for develop software? From where we have to start?
From the client, ma'am.
From the client, okay. What is that stage name?
Requirement, ma'am.
Understanding the requirements.
Yes. You have to collect the requirements from the client or the customer. Then what is the next stage?
Checking if it's possible.
Yes, feasibility study. Next, we are going whether is it feasible to execute the entire thing, all the requirements. Is it possible or not? Then what is the next phase?
Designing.
Designing. Before that, yeah, the analysis part contains the feasibility study. Okay, generally, if you mention the phase name as not a feasibility study, is analysis. Okay, next is designing. So after the designing, so the designing phase, actually we have to focus on the designing phase. How can you design a software development, not in the software, how can you design it? So for the designing phase, we need some tool. If some tools, it's not mandatory thing. The tools are not mandatory thing. I clearly mentioned the tools are not a mandatory thing, but if tools are there, we will get a high quality design and efficiency. Efficiency also will increase. Quality time, you can save the quality time, budget, everything. Suppose if you want to go back and make some modifications, this software, this tool will help you. So what we are going to learn in this laboratory is to use one tool. It's very simple tool only, to draw the design. Means you can do the same designing with a pencil and paper, that's enough. But if it's a complicated figure, this one is reusable thing, right? If you want modification, is very easy with tools. So it's better to go for a tool. We will learn one tool. That's why we called as modeling language, UML. What is the, do you know what is the full form of UML? Or your lab name is Software Engineering Laboratory, but we are focusing on that UML. What is UML?
Unified modeling language.
Unified modeling language. Is it a programming language? Is it a programming language like C, C++, Java, Python?
It's kind of a framework, a general purpose thing.
It's more
It
graphic
is.
based.
Yes. It's not a programming language, it's a visual programming. We are visualizing the designing, and it's not like a usual programming language, what you learn the procedure object programming language. It's a visual programming language, you can so. You can call it as a visual programming, but the programming, but actually there are codes behind that. But when you if you learn the rational rows, one another your modeling language is there. In that one, we can directly give some commands, and based on that, you can see the what is the modifications. Means maybe you have heard about the reverse engineering and forward engineering is there. What is reverse engineering?
I'm breaking down something and understanding it.
Reverse engineering means actually what we said.
I'm breaking thing and copying the exact same thing.
You mean reusability?
Not exactly, but
reverse engineering generally means actually we are starting from this requirement gathering, then next phase is designing, modeling, then going to the development, and last maintenance. That is the normal procedure. But sometimes if you want to modify something, already you've done one project, and if you want to modify again, you can go back and make changes. Then you have the code with you, but you want to make the changes in the designing part. You are going back, whatever you are going before was from start to finish. Now we are going to start from finish to start, means in the reverse way we are moving, means we need to modify something that you have already done before. Then from the code you can make the changes on the modeling or the designing phase. That is reverse engineering. So if you work using a tool, this part is very easy. Reverse engineering part is very easy because the modification is very easy, not like a pen paper problem. So some advantages are there. So I'll share one. Okay, everybody has to maintain one laboratory record. Means an observation book. I'm not sure the entire semester is on offline mode. I'm not sure, online mode or offline mode. This time, probably this semester, I'm not sure about it. Maybe if it is an online class, means we can't submit a record, right? The official record may not be there, but you have to submit the work at last in a PDF form, in soft copy, because anyway a record we are providing some 60 or 50 marks are there. So you have to do the work, but you should maintain an observation book. Observation book is mandatory for everyone. Anyway, at last I will ask you to submit. So use one not ruled book, a plain book. A plain book you have to maintain. No need of Geetham books. Anyway, this time it's not possible to buy one Geetham book, right? So no need of Geetham book, but you should maintain a normal plain notebook as an observation book. And in every class, what we are going to do, that work you have to keep in the form of image or PDF format. I don't know, in Moodle, is there any facility to upload I think it should be in PDF format. In Moodle, may not support the JPEG format or image format. So we can convert into PDF format and save that. That is or record, soft copy record. Do you have a notebook now? A notebook. In the next class, everyone should maintain a notebook. Okay.
Okay, ma'am.
Bring one note next class. So today I will give you a brief introduction to this modeling language. What is it? What is the need of modeling language? What is the role of modeling? If modeling language is not the, is it necessary? Not necessary, but it is good. Okay. To learn, before explain the theory, I'm not sure which one is comfortable to you, whether it's I can directly enter into an example or from theory to example. Anyway, we'll give one brief introduction first. Oh, 1 second. Is it visible? Screen?
Yes, ma'am.
Okay, this is simple theory. I just give an introduction to this theory because you don't know anything about the language, right? So that's why it's a general formals. What is UML? It's a unified modeling language. It's a modeling language because we are going to use this language. Where we are going to use this language for modeling purpose. Why we need modeling? Modeling always we are going for a prototype. Then you will get a clear picture about what you're going to implement actually. So that is modeling purpose. So this is a modeling language. It visualize the way the system has been designed. That's why we call it as a modeling language. It's not like a normal programming language, that you should remember. Anyway, once you go through that examples, you will get a clear picture. Why we are using what I already said, for specifying, visualizing, constructing, and documenting a software system. That is the main purpose of UML language. So this is developed by Grady Book, Ivo Jacobson, and James Rambo at Rational Software in 94-95 time. Okay, these names you should remember because these names are mentioning many modeling languages, not only for one. This is the basic thing which we developed at 94-95. So many modifications comes. Actually, in your lab, we are going to do the star UML. And there are many other UMLs available, and even online versions also available. So you just remember the developer's name, Grady Book, Ivo Jacobson, and James Rambo. And this is the history, means it starts from many versions are like any other operating systems or softwares. Many versions came already. You can see the UML unified method 0.8, 0.9, 1, 1.1, 1.3, 1.4, like that. UML 3, I think 3.4 or 4 is available in the internet. You can download Star UML. That new version is available in the internet. It's an open source where you can download from the net. Then it actually represents a system's model and use. No need to much worry about this part. No need to confuse what is the view. That as a perspective. The view, you just remember the terminology view. I will explain when an example. In an example, I will explain the views. What is the perspective? As a user, you have one perspective, right? User don't know much about the technical side, so he has no view regarding that part, how technically it's implementing. But when it comes to the developer side, developer is worrying about how technical view. His perspective is mainly focusing on technically how we can implement it. So managerial people, they are much worried about the aesthetic sense, everything, all they are worrying about. So different group have different perspective or view about the same project, same thing. So that is the view. So based on that view, we have to draw the diagrams. We divided into different, we have 9 to 12 diagrams are there for every software modeling. In that one, out of 12, we have to learn minimum 9 structural behavioral diagrams are how to draw it. It's very simple thing. You can draw in your own way. So this is the views. You can see the logical view, implementation view, that is the programmer view, and deployment view, that is a system engineer view, and process view, the integrator's view. And as an end user, you have, for example, if you're going to operate an ATM, ATM is also there in your list. Anybody went through that? Have you gone through that syllabus, laboratory syllabus? In that one, you have some 9 projects, right? B11 students, I actually shared that software engineering syllabus. B11 students, I already shared. In the software engineering theory, below you can see the lab syllabus too. Have you gone through it? Theory syllabus actually I shared in that below. Yes. Below you can see the lab syllabus too. So what are the projects in that? What are the projects mentioned in that? Anyone? You have the syllabus with you, right? POS is there. Okay, point of sale. Point of sale system is there. Online shopping is there. Please unmute and tell me. E-library, is there ATM is there or not? E-library, ATM is there? ATM? Yes, ma'am. Okay, ATM is an example. Okay, these we have some projects. I will explain one ATM, then you will get clear picture how you can able to draw it. So for all these projects, you have to draw the 9 diagrams. I will share this PPT with you. So this building blocks you should remember: things, relationships, and diagrams. These are the main building blocks of UML: things, relationships, and diagrams. We have to learn these relationships, things, and diagrams in detail. I will explain in future. And when it comes to things, we have to learn about structural, behavioral, grouping, and annotational diagrams. So these are the 9 diagrams you are going to draw. UML 9 diagrams. You should learn how to draw class diagram, an object diagram, use case diagram.
Ma'am?
Yes.
Ma'am, in UML, do we have to, like, will we get tools for drawing as well?
Yes. That UML software, here we are using Star UML. Star UML, I think 3 and above versions are available in internet. So you can download it. Once, let me check with Moodle people, because one virtual lab facility is there, right? But I didn't see the UML in that list. If it's not there, no problem. We can download. It's an open source where we can download from the net, and we can use it. Okay. So Star UML we can download, but Rational Rose also there. But Rational Rose is not a open source where license versions are there. Okay, Star UML is enough. It's very easy also. In that one, all this diagram for tools are available. Actually, I went through that list in that visual, this virtual lab facility is not available for UML, I think. I didn't see the UML in the list. So if it is not there, no problem. We can download from the net. Okay. Then UML, you should draw these 9 diagrams. We will learn how to draw these diagrams. Class diagram, object, use case, sequence, collaboration, activity, state chart, deployment, and component diagram. Okay, all this diagram is different perspective. Like a use case diagram is a perspective from a user. That is the base diagram. Means, suppose if you are looking at a building, for example, our Geetham building. As a user, you have an idea about the building, but as a developer, means an architect has another idea. So this use case diagram generally explain how the user, it's a user perspective. Use case is a user perspective of the system. Okay, then class and object means, you know, what is a class, what is an object. You know that, right? So class and object is which it is class and object is a perspective of developer. Class diagram and object diagram represent a developer perspective. Why? Because user is not much aware about what is a class. It's not needed, right? What is a class? What is an object? Why should he bother about this part? No need. And this is an internal technical detail. So this class and object diagram as a perspective, it represents the perspective of a developer, and even sequence, collaboration, activity diagrams also, state chart diagrams. Then coming to deployment and component, that is the final part. So even the user or a customer, means user and an end user or a any client. Maybe the client may not be the end user, is a different person. So may or may not be a different person. So that is their perspective. Okay, how to connect those things. So once we explain these models, I think it's better to, here the division, you can see the structural diagrams, what are the different structural diagrams? In the 4 diagrams, class, object, component, deployment diagrams are called structural diagram, which actually represent the structure of the system. Okay, then we have to learn in detail about class diagram, object diagram. Before coming to this, these are the relationships which I already said: unary, aggregation, composition, inheritance, different types of relationships you are using when you draw the diagrams, and multiplicities also you can mention. Okay, these are class diagram things. Before coming to class diagram, I will explain a small, not small, it's a simple perspective, means user perspective. Okay, the user's perspective, example, you know how the ATM system is working, right? Now, is it visible to you? Is it visible? Use case diagram, is it visible or not?
Ma'am, you're in the PDF.
Still in PDF. Okay, then I will change the share. Is it visible now?
Yes, ma'am.
Okay, this is a use case diagram. You know how the ATM machine is working, right? This is the use case diagram of an ATM machine. So how the ATM is working? Anyone? As actually, this is a user perspective. Use case means user perspective. It contains an operator, customer, and bank. These are the actors. And the oval shapes you can see, this is we call use cases. And the lines you can see, some are dotted line, some are line with a triangular end. All these are relationships. The relationships we will learn in detail. And you can see them: include, exclude, extend, captions here. So the main parts, when you are drawing a use case diagram, there are 3 main parts are there. One is actor. Actor is like a human type, human or machine or an organization or something you can call an actor. So this is the actor. Operator is an actor, customer is an actor, bank is an actor. Bank is not a single person, it's an organization. So in those things we can consider as an actor. And oval shape things. Oval shape, you can see the oval shape. This is called use cases. Okay, and the relationship between actor and use cases representing using relationships. These are the relationships. Okay, these lines. Is it visible to you? Is it visible? So everyone knows how the ATM system is working. How the ATM system is working, everybody know. How the ATM system is working, can you tell? Can you please tell me? As a user, because this is a use case diagram, right? Use case diagram is our perspective. As a user, your perspective. So you have to go to the ATM counter with your ATM card.
Credit card or debit card.
Debit card or whatever the card is, you have
And
to
then
go.
you chose your mode of transfer.
Yeah, then.
And then you enter how much amount you want.
Before that, you have to, what is there is a machine, right? Machine panel is there. keyboard is there.
Pen.
And dispenser, cash dispenser is there. Then before you enter the amount, what process is going on there? A validation process is there, right?
We enter the ATM card.
Yes, you have to enter the ATM card, then it will detect and it will ask you to
ATM
enter
pin now.
PIN number. Okay, PIN number validation is there. If the PIN number is not matching with the bank details already, actually request is going to the bank, then they will actually, the software will check whether is it equal, is it the same account or not. Then once it matches, it's a valid PIN. Then it will ask you to, you can withdraw the amount, or you can credit the amount, or you can transfer the amount between many things, or else you need the transaction details or pay slips. There are multiple operations are there. So before that, a validation part is there. So this is a user perspective. As an operator, who is the operator? It's the ATM operator. Your role is customer. You are the customer. What is going on there? A customer has these many options. Withdrawal option is there, deposit option is there, inquiry is there, transfer, many options are there. So before that, this transaction is any kind of transaction. Transaction means it either may be withdrawal, deposit, inquiry, transfer, or is any other options are available. You can draw here. Then what is that? Then you enter the PIN number, right? Before doing these things, you have to enter the PIN number. PIN number, if it is an invalid PIN number, you can't able to. This is an optional case. If it is not the normal thing. If it is not valid, then you can't able to do the transaction. So the bank, you have to take the permission from the bank, and this is a single session, because all the transaction, whether it is deposit, withdrawal, or inquiry, it should be in a single session. So the session, once it starts, you have to finish. And if it is an invalid PIN number, there is no, actually you can draw the same diagram in different ways. And that too, you should remember. This UML diagrams, none of the diagrams are perfect. It is what you are thinking. What is the, you just try to include maximum information in each and every diagram, but another person can draw the same diagram in a much better way. It doesn't mean that the one which you draw is incorrect, but that is what I said. It's a perspective, it's a view. Even not only for this use cases, other diagrams also, a sequential diagram, class diagram, everything. So if you write one program, if you're going to write one program, in your program some classes are there. It's the same program. If somebody else they are going to write, the classes may be different, right? The objects which they are using is different. The number of classes may be different. So when it comes to the class diagram, object diagram also, it is a modeling. It's not the actual code. We are not going for the actual, we are not writing the actual code. So this is a perspective or view about the system. So some classes may be there, may not be there. I should not much worry about that part, but try to include maximum classes, objects, and those use cases in your diagrams. So the operator, what is the operator duties? You just remember a symbol, right? Always the actor symbol should be like this, like a human type of structure. Even though you represent an organization or institution, but still you have to use a human symbol. So then operator duties, system startup, system shutdown, and maintenance. These are the 3 actions performed by the actor. Okay, so the actions performed by the actor and the relationship between the actions and actor. These are the 3 things you should include in every use case diagram. Okay. Is it clear to you? Is it clear? This is not the final use case diagram. You can draw the same ATM diagram in different ways. But you should include the maximum operation. Suppose if you draw the entire thing, it is very complex thing, but just we are not mentioning all the possibilities in our diagrams. Is it clear this diagram is?
Yes, ma'am.
From
Yes,
9?
ma'am.
Yes. Okay, I will show you another diagram, another use case diagram. This is an ATM use case. You should write these diagrams, okay? You should draw these diagrams. I will give you time to draw the diagrams. So let me check once. Okay. This is it visible, this one?
Yes, ma'am.
Yes, ma'am.
Okay, this is another point of sale. Point of sale means nothing. You just, if you go to a supermarket, you're buying some products from there. And what are the process? It varies from supermarket to supermarket, right? But generally, some things are common. So you just try to include the common things. So this is the normal general store structure. You can see a manager. There should be an inventory system, a customer, a cashier, a barcode reader, supplier. This is supermarket case itself. If you're going to a normal shop, this some part may not be there. This, but try to include maximum things. Okay, so a shop manager is there. A shop a customer is there. Cashier is there. Barcode reader, supplier people will be there, and inventory system definitely will be there. So this is the point of sale system. How it works as a user. This is your view as a user. We are not going to the technical part. What is a user perspective? What is the role of a manager? What are the actions manager is going to perform? He can generate the sale report. He can record the depleted inventory. Suppose, what is the duty of manager, a shop manager? Just before going to draw the use case diagram or whatever the diagram is, first you should learn the system. Then only you can draw it. How the system is functioning. This is very simple thing. Anyone can explain? Can you explain it?
Ma'am, he takes care of the store. Like he gets new stock of items, checks
Okay.
like workers stuff, payments and everything.
Yes, that okay. If you have more idea about what the manager is going to do, then you can include those actions also here. This is not that's what I said. It's not a complete diagram. You can include more actions if you know what the manager is going to do. So here only 2 actions mentioned, that is generate a sales report and reorder the depleted inventory. Okay, then can you start from somewhere? What is the customer is going to start from the beginning?
Customer will ask what all products he need,
Mm.
and he will take all the products what he need.
Mm.
And
Actually, that also you can include while drawing here. The customer, all the functions are not included, all the actions are not included here. Okay, then the diagram will be somewhat more complicated, but you can include that also. No problem.
okay, ma'am.
So
Then he
here-
goes.
Mm.
Then he goes to the cash counter for the billing.
Mm. Actually, the
And what-
checkout session is explaining here. Then how he's picking the things from the store. That part is really missing here. The items he's choosing. That part is not written draw in this diagram, but you can draw. No problem. Mm.
And after picking all the items, first he will check that all the items are there in his basket or not,
Mm.
and then he go for he will be waiting in a queue line for billing,
Mm.
and the cashier will bill the customer's items
Yeah,
billing.
in this diagram it's mentioned the checkout part. While going for
Yes,
checkout, the payment different
next-
methods.
Next he will pay the payment, total bill payment, using
Yes.
his cash or
It may be
any
either cash mode or credit card mode or debit card mode. Yes, he can choose any of the options. These options will be available there. And he's connected to the customer is interacting with the cashier in this period. So in the checkout time, we are interacting as a customer, we are interacting with the cashier. At the time, if you are not satisfied with any of the product, or if you don't want the product, you can return the product items.
Yes, ma'am.
Yeah, the return items also one it's showing. Okay. If it's not there, also it's not wrong. Okay, you can include your ideas. But this is the as a user, as a customer, if you approach on supermarket, this last part is yours. This customer, the interaction, you are interacting with the customer and cashier. Sometimes we will take the interaction with the shop, what that people we call shop, not managers. Suppliers will be there, right? What is suppliers? This is the product supplier. Here is showing the product supplier. Okay. Then he is actually related to the inventory. Then manager is related to the sales report, and you know what are the other actions shop manager is performing that you can include here. No problem. And inventory. whether what is his main role actually, what the shop manager is, that you should not miss. What is his main role? He always check the inventory, whether the product is available or not. If it's not available, then he has to order,
Place the order.
place the order, and at the same time, there is a book, right? Register. He has to update
Enter.
that.
Yes, ma'am.
Update that book. Where if suppose if every day he has to check that whether the what is there in the shelf. If it is already sold out, you have to mark it there. That part should.
No,
That
ma'am.
is-
The workers will check and he will give it to the manager
Yeah.
to update the
Yeah, but who will update it? The shop manager, right?
manager will update.
Anyway, the workers, they won't update it directly. So
Yes, ma'am.
manager's duty. It is a manager duty. Okay, he's collecting the information from the workers.
Yes.
Okay, that you can draw. Then coming to inventory system, it's a tax part, calculation of tax part, and inventory updation, those part by another system. Maybe it's a person, separate person maybe there. Then barcode reader. Barcode reader is there. Barcode reader is using when you scan the items, right? So scan the item, read the barcodes, and all that is done by the barcode reader. Okay, I already said it's maybe a machine. The actor may be a machine, a person, or an organization. So if that type of things are included in your diagram, you can draw this, use the actor symbol. We call it as an actor. Okay, cashier. Supplier, is it clear, this diagram? You can draw in another way also, okay? You can think about in your own way. And if you can able to draw in much better way, you can draw it. This is enough. This is the point of sale system. Use case diagram. Is it clear about use case diagram? What is a use case diagram? Is it? This is a overall means overview of the system. I can say the use case diagram is an overview of the system. We are not at all bothered about the internal details, how it is working. That we are not bothered about. So that is a use case diagram, is one of the simplest diagram among all the 9 diagrams. If you want to draw how the system is functioning, if you want to draw about any of this diagram, any of this use case diagram, you should learn how the system is functioning. If you know how the system is working, then you can draw it. Okay. Is it clear to everyone?
Yes, ma'am.
I'm getting only one response of 105 students. Do you have any doubts? Do you have any doubts? It's clear. From B9 students responding. What about B11? I'm getting response from B9.
I'm on B11, ma'am.
Ma'am, we are B11, ma'am.
Okay, okay. B11 students are responding through microphone, B9 by chat. But I think 105 students are there, but I'm not getting that many responses. Is it clear? It's not, I already said it's not like a programming language there. We are expecting, we have an expected output, right? We are checking always with expected output, whether it is matching. If it is not the exact output what we are expecting, then we could say that this is wrong. But in coming to the modeling language, there is nothing wrong. It's your perspective. And this will help you to develop the product. When you are developing the code, this diagrams will give you an input. That's it. Okay. So we couldn't say that this one is wrong, the other one is correct. But when you develop a system by your own, you should be very clear about the system. Then only you can. But this is very difficult task actually. This designing is very difficult task because you should be very clear about each and every part of the system, how it's functioning. You should not miss anything. Okay, the designing phase input is the user requirement collection. Whatever the requirements you collected from the user, that is the input to the design phase. So if you collect the information correctly, and if there is no misunderstanding between the requirement engineer and client, then only you can draw for a perfect model. If the modeling is correct, then only you will include every details in your development side. So all these things are interrelated things. So that's what I said, the requirement gathering is very, very difficult task. If the requirement gathering time, if you want to collect the things perfectly, you can't develop a system, a model correctly. And if the model is not correct, definitely your development also will not be easy. And you may miss something details. So is it clear or not?
Yes, ma'am. Clear, ma'am.
It's clear. Then I will give you one question. Everybody has to try to draw using pencil and paper, not with the tool. The tool, actually the same thing we are going to draw using tools. I'll show you next class. How can we draw using tools? So I will give you one question. That last 1 hour, you can try in your own way. I'll ask someone to share their screen, share their idea. Okay, you are very much clear about online shopping, right? Online shopping.
Yes, ma'am.
Okay. Try to draw a use case diagram on online shopping. So the main characters in this, like actor should be there, actions should be there, means use cases, and the relation should be there. Now you know, actually did not explain the relationships now, right? But you just try, just use the normal line. You should not bother about the exact relationship with arrowhead. You should not worry about that. Simply draw using the normal line. Okay, everybody has to try. Online shop. Use case diagram on online shop. I'll give you half an hour time. You can think about it. Anyway, everyone is doing this thing, right? You know how you are purchasing something from the Amazon or Flipkart or some other online system? What are the stages? Try to do that. Now time is 3:07. You can take half an hour. No need of system study. That's why I give this question. No need to study the system. Everyone knows how this system is performing, right?
Ma'am, can you share the screen with the store example?
The previous one, point of
Yes.
sale.
Yes, ma'am.
Okay. One second. What is the difference between a point of sale system and online shopping?
Nothing, ma'am.
Difference is there. Online shopping managers only
Customer care, ma'am.
those part you should not do. Sales diagrams. Is it visible?
Yes, ma'am.
Everyone has to draw this diagram. Again, I'm telling you, this is a user area, so user perspective. So as a customer, when you buy something from Amazon, what are the stages you're going to perform? Are you drawing?
Yes, ma'am.
Try anyway. Try it. Are you trying?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Are you getting? Are you getting? Can you able to generate the ideas?
Yes, ma'am.
Okay, which relationship you used here? All are associations only, right? The direct link. Okay, then do it as homework. I will explain the relationship also. Then you can include that. If it is necessary, you can include that relationship also. Okay, do this one as homework. Everybody has to do it. An online shopping use case diagram designing. Okay. Then I will explain. Actually, this use case diagram comes under behavioral diagram. Okay. Behavioral diagram. Behavior where we have to. Okay, I will ask you in next class. I will pick random students to share their screen. Everyone has to work. Whether it is correct or not, that is secondary thing. You should try. Okay, then this use case diagram, sequence, collaboration, state chart, and activity diagram. These 5 diagrams are called behavioral diagram. Means we are representing behavior of the system, not the structure. We are representing the behavior. Okay, use case diagram generally contains actors. This is the actor. The passenger. This is simply use case diagram. Part of use case diagram. It represents the passenger, and passenger purchase the ticket. How can you represent this relation? A passenger is an actor, and purchase the ticket is the action which is going to perform. So the purchase ticket is the action part that we are writing in use case. Use case is the shape of use case. Or this is the functionality. Okay, then passenger, and you can see a line in between. This is a simple relationship. This is called association. Association is always representing as a single line. There is no pointed arrows. Nothing is there. A single line which we call an association. Suppose if you are not clear about the exact relationship, you can use this association in other relationships too. So the actor may be a user, he is an external or an external system or a physical environment. So not like the passenger. Before example, we use ATM machine, that inventory system, all this we consider as an actor. It is. So not only the person. When we hear about an actor, you always think about a single person, right? So this is either a system or an environment or user. The use case diagram is a functionality of the particular the action performed by the actor. That's called use case diagram. The use case consists of a name, participating actor, entry conditions, flow of events, exit conditions, special requirement you can mention in the use case. Any of these things you can represent in use case. So the main relationships here we are using are association, generalization, extension, include, and these are the main relationship. Generalization of the actor or the use case. So when you draw the diagram, if you before I did not mention the relationships, which one, what is the exact relation, then you can go for a normal line, that is an association. Where we are using this generalization account, you can see this is an association between an actor and use case. You can see this is a customer and bank employee. Suppose if you are going to deposit some fund, first you have to open the account and then you can deposit the fund. So the relationship between a customer and bank employee, that you can use a normal association. There is no particular specification is not there. So you can go for a normal associative relationship between a customer and a bank employee. And we just go to the bank and open an account and you can deposit the fund. So when here you can see this is also a same relationship, but you can see a non-resident person, suppose a foreign person, he has an NRFC customer. He's an NRFC customer. He belongs to the customer group, but he is something special, right? He himself has a privilege to convert the currency. So that one is a separate thing. So you can go for association, generalization. This is the generalization. A triangle head means a pointed arrowhead, but it should be in this form, not a normal pointer. No, normal arrow, like a triangular shaped arrow. So this tools are available in the UML, star UML or other tools. These things are available. So you can use the relationships. So where to use the relationships, you should be clear. The NRFC customer is a customer itself, but he has a privilege to go for the convert currency. So he is connecting with the actual customer group in a generalized, that we can call as generalization relationships. Where we use this in ATM diagram, do you remember? Where we use the symbol in ATM diagram? ATM use case diagram. Anyone? Generalization, where we used it? Am I audible?
Bank.
Yes, bank. In point of sale system also we use that. In suppose if you're in point of sale system we used, right? Where we used it? Suppose if you're going to pay the money, you have many options available. That also you can represent in the form of generalization. That relationship you can represent in the form of generalization. Okay, different cash on delivery or means
Online payment.
Online payments mode or cash delivery. Cash you can give directly. Credit card, debit card, those features. Google Pay. If Google Pay is there, you can go for those. Multiple options are available. Then you can go for the generalization instead of association. Then extend relationship. Here you can see the same use case diagram which we have given. In that one, extend relation. Extend means suppose a normal customer is going to open an account and he deposits some amount, but there is some extra or exceptional cases of it. Like if the amount over 10,000 or age over 55, he will get a bonus. So only for though if this particular requirements, if this particular condition is satisfied, then he will get a bonus. This is not general. This is not for every customer. This is only for a group of customers who satisfy this condition. If the amount over 10,000 or age, he belongs to senior citizen group, he will get a bonus. So this is an extended thing than the normal thing or an exceptional thing. It's not a normal case. Then you can consider this an extend. You can use this symbol extend. Then you can use another one is include. Include is extend and include, these two you can use. Include means For example, you withdraw the fund from the amount you deposited. Then you need to update the balance, right? You have it should be debited from the actual account. So that part is called include. This thing can include this update balance can include with the actual operation. So this is called include. Where we are using this operation, you should be aware about it. So extend, include operations. You can add this other association, generalization. These are the main relationships you need to remember. Use case, when you're going to draw the use case diagram. Okay. So, for example, suppose if you are going to design a use case diagram to purchase a ticket by a passenger. So the entry condition, the passenger standing in front of the ticket distributor, and passenger, he has sufficient amount of money with him to purchase a ticket. So exceptional case, some exceptional case means he does not have a sufficient amount to purchase the ticket. That's an exceptional case. So you can extend that too in your extend that relation. For example, passenger is going to purchase the ticket. So some extended cases means some exceptional cases may come, like out of order. System is out of order, or you want to cancel. Okay, no need to purchase ticket. No, you want to cancel it now. Suppose if you don't have changes or the timeout, any of these exceptional cases comes, you can use the extend. Is it clear? Extend relationship. Is it clear? Is it clear or not?
Yes, ma'am.
Means exceptional events means that are not normal thing, right? The normal event flow is there, but something happened than the normal. That is comes under extend. Okay. Then include. This is an example. Include. So here the passenger purchase a single ticket or purchase a multi-card ticket. So this include first collect money. Collect money means these two are extended operations. Why? Because when they're going to collect the money, there's a chance to not change, or he may cancel the operation. So these two, there are many kind of extend means there are many exceptional cases, possibilities are there that you can include in extend, but include here, these two are included in this collect money. What is it? May be a purchase single card or multi-card. So an extra operation that is called include. That also you can include in that relationship. That is called include. So okay, here also you can see the generalization where we are using extend and include operations. So for example, in generalization, the transaction is either withdrawal, deposit, transfer, or inquiry. So any of this comes, you can use the generalization. Okay. Then invalid win is a chance. It's an exceptional case, not the normal. It's not comes under normal flow of operation. Something may happen as an extended operation. So this is called invalid win. You can connect with an extended operation. Okay. Is it clear?
Yes,
Is
ma'am.
it clear? How many of you are listening? It's 3:48. I'm going to end the session. If you have any doubt, ask me right now.
No doubt.
No doubts. Is it clear? The relationship should be very much clear. Then only you can draw the exact figure. So what I am planning to do is, after completing the ATM all 9 diagrams, I will ask you to draw in your star unit. Because in first project, you should draw with pencil and paper. Then only you will think about it. Instead of going to draw in star UML. Once we finish all the 9 diagrams, I'll ask you to draw in the star UML. Star UML tool is very easy. What you are going to, we are just picking these things and connecting. But instead of that, first, when you draw in paper, then I think at least you will think about it. When you are drag and drop only, this UML symbols, all the symbols are available in Toolkit. So you can simply drag and drop, that's it, in star UML. So the first project, I will ask you to draw entire 9 diagrams, all the 9 diagrams in a paper. I mean book, observation book, not paper, in observation book. Okay, so once we finish the 9 diagrams, the remaining all projects, we can use the star UML. Then you can save that diagrams and take the JPEG image. We can convert, that option is there, and take a printout and paste it. Okay, that's okay. No need to draw every diagrams. At least they should not transfer someone's work to your account and should not modify the names. That is not allowed. Should not do that. So, if I find that definitely everybody has to draw each and every. So 10 project means 9 diagrams for every single project, means nearly 90 diagrams will come, right? So you can draw directly on the star UML next time. Next time means after finishing the first project, ATM. Okay, after ATM, everyone should draw in your notebook. Remaining on observation book. So be ready with your observation book in the next class. Okay, is it clear to everyone?
Yes, ma'am. Clear, ma'am.
Yes, ma'am.
Okay, just raise your hand. How many of you listen this class? I just want to know how many of you listen this class. Raise your hands.